Yeah. So what I'm doing here is I'm finding my y value because I have now my slope, so this is the dy dx, but now I want the equation of the line. So it's y minus the y value. Well, what's the y value? Well, y is equal to r times sine of theta. So first of all, let's find r at theta equals 3 pi over 4. They give me theta equals 3 pi over 4. So what's the r value when theta is equal to 3 pi over 4? Well, r of anything, so r is dependent on theta. R is equal to sine of 2 theta. So sine of 2 times 3 pi over 4 is the same as sine of 3 pi over 2. At 3 pi over 2, the r value, or sine value, is negative 1. So that's r, so it's negative 1 times sine of 3 pi over 4. So what's sine of 3 pi over 4? Root 2 over 2. So this is going to be negative root 2 over 2. Let's do the same thing with the x value. X equals r cosine theta. So x of 3 pi over 4 is equal to the r. Well, the r value is going to be the same, right? Because the r is still the same and the theta is still the same. Agreed? R is sine of 2 theta. So the r in this case is just negative 1 times cosine of 3 pi over 4. So the cosine of 3 pi over 4 is negative root 2 over 2 times negative 1 is positive root 2 over 2. That's what r is. So they give us that r equals sine of 2 theta. So if I want x, well, x equals r times cosine theta. So first of all, what's r when theta is 3 pi over 4? Because this is really r of theta. If you think about this r of theta, it's dependent on theta. It's defined in terms of theta. So when theta is 3 pi over 4, inside here is 3 pi over 2. Sine of 3 pi over 2 is negative 1. That's where that negative 1 came from. Okay, and now this is my equation of the tangent line right here. Obviously, you could simplify it a little bit if you, y plus root 2 over 2 equals x minus root 2 over 2. Or if you subtracted root 2 over 2 from both sides, you'd get y equals x minus root 2. Something like that. And that's what we got going on. That's the equation of the tangent line. They have in the book just y plus root 2 over 2 equals 1 times quantity x minus root 2 over 2. So they had, what I had there, they just made that, they slash and slash to get that. So how is that? Okay? Where are we at time-wise? Bihar?
3 minutes, 56 seconds.
3 minutes?
Yeah, I started over because you almost went over 15.
Neat. Good job. Okay, so now, my question to you is this. So we've talked about dy dx. We know what that is. Just the slope of the tangent line. What's dr d theta? What does that mean to us? Because we're using it in dy dx, we have dr d thetas, right? No. Dr d theta. Just in terms of what you know about related rates, what do you suppose dr d theta? Good. So as theta increases, remember what theta increasing means now though. No longer are we moving around along the x-axis, right, as x increases or as time increases, but now as theta increases. So the way that we describe this is as theta sweeps through, right? So when theta is increasing, it's like the hands on a clock, right? They're going around and around and around. And so theta is increasing means that it's sweeping through, right? And so if theta is increasing and the R value is increasing, talk to me about what's happening here. Let's just assume, for this example, my initial R value, so when theta is equal to 0, R is equal to 1. And as theta sweeps through, R is increasing. Yes?
Wouldn't it be like kind of like what you drew earlier where it like starts really little and then it gets like
So it's like, it would spiral a little bit, right? It's, if here's, our initial R value is only like 1. Then it's increasing, and increasing, and increasing, and increasing, and right? Your R value is increasing as theta increases or sweeps through. Okay? So listen to what I'm about to say and tell me if this is true or false. If dr d theta is positive, then the point is moving away from the pole or the origin. Let me say it again. If dr d theta is positive, then the point is moving away from the pole or origin.
R is increasing.
Yeah.
False.
Why false? Give me an example of when it would be false.
Because it could be the radius could be decreasing and there could be a negative angle and it'd be like inverse.
No, remember so when we deal with dy dx, x is the thing always increasing. When we deal with dx dt, t is always increasing. Dr d theta, theta is always increasing. Theta can be negative, but then like that the positive or negative has no bearing on whether it's increasing or not. Theta can be negative, R can be negative. But all I'm asking is, if I give you that dr d theta is positive, does that guarantee that the point is moving further away from the pole? Do you think yes or no? So the answer is sometimes. Only if R is positive. If R is positive and dr d theta is positive, then that means that R is moving further away from the pole. If R is negative, so let's say when theta is equal to 0, I'm back at this negative value. Watch what's going to happen. As my theta value sweeps through, the point is R is increasing, meaning getting less negative. Right? Do you know what I'm saying? So if R, an image of that would be this. If I have this initial point right there. So R equals, so theta equals 0 and R equals -4. Right? So my theta value is 0. But then R is -4, so it puts me over here. So now, as theta increases, so if I go up to theta equals pi over 4, and if R is increasing, maybe now I'm at -3. So that distance is going to be closer here. And as theta increases to pi halves,
That means only being closer to the center if it's less than 0.
don't say it.
R is less than 0.
And d r d theta is positive? Yes. So at theta equals pi halves, r is still increasing. So maybe now it's only at -2. And at 3 pi halves, 3 pi fourths, what happened? At 3 pi fourths, then all of a sudden your theta value, your r value is only at like -1. So it's been increasing from -4, -3, -2, -1, and then maybe at pi, at theta equals pi, you're then at 0. So really, the path of this guy went like this, which is a very common path of a polar curve. So when it comes down to it, it's like this. Because this is a pretty common question on the AP exam. Is a particle moving closer to or away from the pole or the origin? Well, if r and dr d theta are the same sign, the particle or point, whatever you want to call it, point, is moving away from the origin, sometimes referred to as pole. So this is very important. And then I will say, if r and dr d theta are different or opposite signs, the point is moving toward the origin or pole. Okay? So this is an important thing to note. And it's kind of related to the whole idea about velocity and acceleration, right? If velocity is positive, that means that you're moving to the right. And then if acceleration is positive, that means that you're moving to the right faster. And so you're speeding up. If the velocity and acceleration are both negative, then you're speeding up. So in motion on a line, if the velocity and acceleration are the same sign, you're speeding up. And if the velocity and acceleration are the opposite sign, then you're slowing down. But in polar, if r and dr d theta are the same sign, the particle is moving away from the pole. But if they're opposite signs, then the particle is moving closer to the pole.
But then, for R on that example, since it's -4, what happens once it becomes positive?
Then r and dr d theta are the same sign, then it would start moving away from the pole. So it's getting closer to the pole, closer, 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 closer. It's at the pole. And then it starts getting bigger, 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 bigger. So then it's moving away from the pole. Just like concavity could change, or increase, decrease could change, or everything else could change, yes. And theta sweeps through. Now, when we're talking about dy dx and all that stuff, it's at a set theta value, right? But all I'm saying is using r and dr d theta to have some type of idea of what's happening with the particle moving. All right, your homework tonight. You only have problems 37 through 42, and it's only based on the derivative. We never talk about second derivative with polar, only with parametric. Cool? Cool.